A very good morning to everyone present here. This is K. Deepika, Assistant Professor, Mechanical Department. I take this privilege to extend warm welcome to all presented here. On behalf of Mechanical Department, Guru Nanak Institute of Technology, I heartily welcome you all for this live webinar on Industry 4.0. It's my pleasure to introduce today's guest speaker, Dr. Kaushik Kumar Sir, Associate Professor, Department of Mechanical Engineering, Birla Institute of Technology, Ranchi. Dr. Kaushik Kumar Sir was pursued his BTech in Mechanical Engineering from NIT Warangal, and he completed his MBA Marketing from Indira Gandhi National Open University and PhD from Jadavpur University. He has 19 years of teaching and research experience and over 11 years of industrial experience in a manufacturing unit of global repute. His areas of teaching are research interest are composites, optimization, non-conventional machining, CAD/CAM, rapid prototyping, and quality management systems. I extend my welcome to all professors, all faculty members, students, participants who all gathered here to add radiance to the session. Once again, I welcome you all. Now, I request our guest speaker, Dr. Kaushik Kumar Sir, to address the session. Thank you, sir.
Thank you. Sir,
Yes, sir, you are audible.
yeah. Just a minute. Sir, can you put me as presenter?
Oh, sir, just a minute. So I think, I can close the sharing. You can start, huh?
Yeah.
So now you can start from
Yeah.
present, sir.
Sir, is my screen visible?
No, sir. You are visible, but your presentation is not visible.
Just a minute, sir.
Now it is come. Yeah. Okay, sir. Yes, nice, sir. Okay, sir.
Okay. Good morning to one and all.
Good morning, sir.
Thank you, Professor Vijay Kumar, the people of Mechanical Engineering Department, the participants. I'm very thankful to the people down there who had invited me for this resource person as a resource person for this webinar. The viability of this industry 4.0 and the essentiality of this 4.0 has become very, very pertinent in this COVID situation. Most of us are almost stranded. The manufacturing sector, the education sector, everywhere we are having some problem, and the only solution that is coming out to us is the internet or the virtual connections, and that is where this industry 4.0 talks about. Sir, if you excuse me, can I just uh, switch off my camera?
Okay, yes, sir. You can.
Is it visible now, sir?
Yeah, visible. You can, sir. Carry on.
So, if we go into the industrial revolution history, it started in late 1700 with the development or invention of the steam engine. James Watt. Actually, he started the industrialization, or before that, we were having non-mechanized power, mostly the human and animal power for working out with different functions, which actually got mechanized with the use of steam engine, weaving loom, and all these things. Then around, say, 100 years from then, we had the second industrial revolution, that is Industry 2.0, which actually talked about the mass production. Because once we started production, now it became that we have to produce more and more. And in that case, it has to be under mass production with assembly lines. And here, apart from the steam engine or mechanical power, now electrical power was introduced because that was more compact. For example, if you see the power that we get from electricity and the power we are going to get from, say, steam and other thing, the volume basically varies. Now, once we started with this mass production assembly line with the help of electrical energy, about 100 years, we had the third industrial revolution, that is Industry 3.0, wherein now we have started into automation part with computers and electronics. They were helping us with the mass production and the various aspects of manufacturing sector. Now, this was a bit required because whenever we go for a mass production, even with the aid of any electrical energy, actually it's the human assistance or human presence was very much required. Now, the moment we have a person working on any system, the repeatability becomes a big question. And this non-similar products, you can say, similar in the sense non-identical products, I should say, was creating some sort of rejections. The productivity was going down. So they wanted to make it automated so that with the help of computers and electronic circuits, that the repeatability and the product characteristics were identical. But then after 100 years from then, we actually went into a system where it was not at all mass production now. It became a customized production. And I remember in somewhere around 1980s, when we were expected to buy a scooter, especially that time we had only two companies providing the scooters. One was Lemreta and one was Bajaj. And normally you would never get a scooter just going on to a store. You would have to book it, and it would take around 6 months before it used to come to you. Now, with the globalization and other things, other aspect, and the demand Now people went into, they were in requirement of the products very fast, and they wanted to customize it as per their requirement. Now, with this, we have today the Industry 4.0. Basically, it is the customization of the product. Today, we are not very much interested about mass production because there are certain problems with mass production. Like today, people are constantly going in for something more, something else, something different. And this something different or something more actually has reduced the product life cycle of any product. And in order to cope up with this smaller product life cycle, we cannot go for very mass production. Like if you just recollect, if you today buy, say, a simple thing, a pen, a ball pen, and around, say, 6 months after this, you go to a shop and ask for a refill of the same, there's a high chance that he will not be able to give you, because he will say this is outdated, better you buy a new pen. So that's the life cycle period of any product that's coming up. If you see the car, every other day you will find a new car being launched, and as it is launched, if the product is not very much into the system, for example, Maruti 800, one of the most sold vehicle, actually that has gone off the market. And if you are using it, then it will be very difficult for you to get the spare parts unless and until it matches with Maruti Alto or any other vehicle. So this has become the situation. So we cannot go for rejections. We cannot go for a situation where the customer says that I don't want it. So we have to produce something which the customer wants, which the customer needs, and which the customer approves, rather than producing in mass scale. So that has been the main essence of Industry 4.0. And if you see to that, you'll find that basically Industry 4.0 has been designed towards development a new generation of smart factories, or currently coined as customized or tabletop factories, where we require a lot of flexibility in manufacturing, in production. We require the personalization, the customization of product, instead of making it in mass scale. Because today it is not the seller's market anymore, it has to be a buyer market. So this problem, so now we require a facility to be provided to a customer situated in one side of the globe to control and monitor the production in a manufacturing unit available in other side of the world, where he will be controlling, today, if the shop is in Singapore, the manufacturing unit is in Singapore, sitting in India, I can control the production, I can see the product being manufactured, and I can always comment on it that this is not what I wanted. So this radical change actually has initiated the Industry 4.0. Now, if we talk about how this is supposed to happen, so there are certain components of Industry 4.0. I'll be trying to discuss some of them in detail. For example, the big data. Now, with automation, with microprocessors, with different computer-aided instruments and facilities, we are getting a lot of data. If you remember, if you have worked with a tensile testing machine, a UTM, earlier days, somewhere in 90s, we used to have a big machine and the data was supposed to come it through a roller, in which we used to put a graph paper and we used to get some data. And normally these data were very, very limited. We used to get around 4 to 5 or max 10 data for a stress strain curve. But today, if you use a microprocessor machine, Instron, you will get lakhs and lakhs of data. Now, generation of data has become almost 1,000 times what we used to get earlier days. Now, the problem is storage of this data, analysis of this data, and prediction or speculation from this particular data, working with this data. Then we have the, in order to do that, we have the cloud computing system, where all the data are kept in a bundle in somewhere in a data cloud, and we apply the techniques, whatever technique we want to do there itself, and it takes up the results and gives me the results back. Now, in doing so, actually, we have to adapt the equipment accordingly. For example, I'm doing some testing, and I find that there is a slippage in the tensile testing machine. The grips are not properly fixed on the product or on the sample. So the cloud computing tells me that the data what you're getting is not as per required. So then the machine should be able to have a feedback that this is because of the fault in mind, not the fault in data. So it should adapt itself of its own, and it changes the grip. Once the grip is changed, automatically the data is generated would be much more authentic and much more perfect. Now, with this machine learning, we go into a new system of robots that is known as a cobot, collaborative robot. Now, there is a difference between cobot and a robot. I'll come down when I discuss this. Now, before producing something, for example, I can tell you when I was working in a company somewhere in 95, 96, we used to make some molds, some dies for some product. Now, it used to take us around more than a year to finalize that die, because we used to do the product, die, we used to create product out of it, and the product was tested. Sometimes the product used to take around 1 month to settle down and then get tested, whatever it is. So then the changes were provided. We used to put those changes in the mold, and then again the die or the mold was subjected to production. Again, products were produced, again it was tested, and this cycle used to go on and on till the product was satisfactory. Now, today what we require, today the customer doesn't have that much of time, neither the product has, because the product life cycle has gone down. So what we require is a virtual system where the whole thing will be done in a virtual medium and we will know about it. So there is a software, for example, in around 2000, when I was planning to come to BIT Mesra. That time we were working with a software called Moldflow. Now there we used to put the die, and it used to give us the simulation where the data were given, and we used to know that what will be the stresses, what will be the elongation, what will be the deflection, and all these things. All data were provided to us virtually. So we used to change the model instantly and again used to check. So what we were doing in 1 year. Basically, that started happening in an hour. And within an hour, we used to get the final shape and size of the die or the mold, which we can directly manufacture. And with 1 or 2 alterations, we can come out with the product to our satisfaction. Now when we are trying to do this, basically we started using IoT, that is Internet of Things, where internet was used in order to communicate between the customer and the manufacturer. And this Internet of Things were so much pertinent that it started having some more branches, some more specializations. And all these things, then we went into the 3D printing, where the designer becomes the manufacturer. I think I have talked a lot about 3D printing in your earlier FDPs. Vijay Kumar sir?
Hello?
Yeah.
Yes, sir. Tell.
We had discussed a lot about 3D printing, I presume.
Yeah. In the STTP.
Your, 3D
And,
printing, 4D printing,
FDP,
3D printing.
Faculty development program we have discussed in the previous
So
semester.
I'll not go into it. Anyway, in my presentation, I'll be talking about it as well. But this is the scenario where we are supposed to work today. And this has become very much essential, especially in this COVID situation, when the customer is unable to come down to the manufacturer, or the designer is unable to go to the manufacturer, or the manufacturer is unable to go it to the inspection people, and all these things. Everybody is more or less working from home. So when we are working from home, this system is the only solution where we can have a complete better manufacturing, and the industry would be more beneficial. So these are some of the components I would be talking about. Now, Internet of Things. Actually, it is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifier and ability to transfer data over a network without requiring human to human or human to computer interaction. Now, this term actually was actually talked about Internet for Things. But ultimately, it became Internet of Things. This was Internet to be used for things, not just for transferring means for virtual communications. Apart from
Yes, sir. You're right, sir. This is the correct word. Internet for things.
Yeah, actually,
Because-
it was coined. He preferred it as Internet for Things, but ultimately it came out to Internet of Things. Means the term was later on coined with some, I don't know for what reason, but it got converted from Internet for Things to Internet of Things. Now, actually, it is where the things are connected through internet than people. Means I can connect a manufacturing machine through internet to perform, where I will be controlling the buttons. Now, many machines are available where you can work, like there are this 5-axis machines which can be directly operated through internet, where even the customer can go in operating that. So that is what we are now heading towards. Now, this Internet of Things, there are many many applications. and it became so powerful that we started having industrial application, military application, battlefield application, ocean application, and with all different names like Internet of Military Things, Internet of Battlefield Things, Internet of Ocean of Things, then Internet of Industrial Things, IIoT, Industrial Internet of Things. So this became so popular and this became so powerful that we started having specialization in every sector. There are agricultural system, medical and healthcare, all are having their own. For example, I would like to have a field in which I would like to sprinkle some medicine. Now, I don't have to drive anything. I have this drone. The drone can be operated through internet and it can be used for sprinkling of the medicine over the field completely. So even agriculture is affected, your medical science is affected. Like in this COVID situation, I think most of the doctors, they are preferring to have a virtual diagnostic center rather than the actual one. Isn't it, Vijay Kumar sir?
Yes, sir.
If you take an appointment today of a doctor, he will say that my virtual chamber opens at 11 o'clock in the night. You please come with your prescription and other things on a video call. There you are going to tell me your problem. I'm going to suggest you the medicine. So this is what the things are going on. Means it is not only concentrated to the manufacturing world. Now this has gone into almost all the sectors, the transportation, everywhere. Like if you book a ticket on a flight, you have an option of choosing the seat where virtually a flight is shown to you. And you say that, okay, I'll take the window seat, or I'll take the middle one, or I'll take the L1, or whatever it is. Similarly, if you go into the architecture, earlier we used to, if today I want to buy a flat, I'll no longer be shown a blueprint. Rather, I'll be walking through a virtual flat that has been created. And this is working through internet, and staying somewhere else, I can always access that flat, look into the flat, how it's supposed to look like through a walk-in video or walk-in system. So this is the power of the system what we are working with now. Similarly, we have, this industrial Internet of Things, that has become almost equally powerful because it is concerning to all the industries. So that's why we have a separate section of IIoT, which actually is a part of IoT, but we call it in a separate way because of its own huge importance.
And such a small break. I would like to interrupt you. One more example is just like during this present pandemic situation, the industries and R&D centers, they are executing the whatever the output and the experimentation, and they could able to show to the whatever the students and the research fellows, and through the Internet of Things only. That is virtual creating and live also.
Labs. You are taking labs.
Yeah, labs. And lab demonstration, and
everything is now through internet in a virtual medium.
Yes, sir. So this is not one of the application of the. Already we have started Industry 4.0. We are able to, because of the pandemic situation, we have been entered already. All activities are going on online only. Doctor's prescription, doctor guidance, everything, surgeries. This is what the beauty and advancement of the
No, actually,
Industry
we
4.0.
were forced to go into this
Yes,
Industry
sir.
4.0 because of this pandemic.
Yes, sir. Now the
We,
pandemic made us to
yeah,
start implementing
yeah,
worldwide, and also it is a message and lesson to the learners, the graduates also. You don't sleep. You start learning the things which are required to survive in future, to give the better service to the world,
yeah,
using the advanced technology, upgrade the technology. This is the pandemic. But we are criticizing the pandemic, but we are scared. But we should not scare. It is an opportunity to do innovation, invention. This is the role of engineer. They should take it a challenge and they should feel opportunity. Then they can implement. This is what COVID-19 has given the big message and uh, wake up call, I think. Huh?
yeah.
Okay, sir. You continue, sir.
No problem.
Okay.
Yeah.
Mm.
So basically, in industrial Internet of Things, it is Internet of Things concentrated towards the industry. Now, the industry can be any industry. It can be your manufacturing unit. It can be a medical unit. It can be a defense unit. It can be anything. Research unit, educational unit. Everywhere we are trying to work out with this, utilize this internet system. Now, the application can be automotive industry, oil and gas industry. So these are certain parts where we are using the IIoT. So we get a lot of digitalization for car manufacturing. For today, we test a car. I hail from a place called